Thanks to Fiverr for sponsoring this video. I don't make games very often, but when I do, they're usually remakes of the first game that I ever made. Refresher, the first game I made is this thing here. Pretty tame looking until you uncover what's really going on. I made this all the way back in 2012 when I was in my last year of high school. I was just learning programming and Ludum Dare 24 came along and I was like, why not? Now, since I was busy with school that weekend and I had to study, I only ended up spending about 20 hours on the game, but the game was a hit. At least in my high school, people seemed to like it. Wonder why. The original game was made in Java and it had some issues. Did I mention this was my first game? So earlier this year, I thought I'd try and remake the game using C++ and Raylib and see if I could, resolve all of those issues. Because I'm a real programmer now. Anyway, that went pretty well. You can actually download and play that game. I'll leave a link in the description below, as well as a link to the video that shows me remaking it. The full version of me doing that, like the full 12-hour or whatever live stream, I finally uploaded to Cherno Unplugged for those of you who missed it, because I said I'd do it, but I didn't. I do that a lot, I'm sorry. But something was wrong. It just didn't feel right. It was as if my vision just hadn't been fully realized. Even though, yes, I had fixed the game with everything that I had learned in the last 12 years of programming, something was missing. The third dimension. Yes, that will really help bring my vision to life. But how do you take a 2D game and make it 3D? Oh wait, I should probably get the camera up. Anyway, where were we? Oh yeah, 3D game. But how will I make a 3D game? It's like harder than 2D, right? Oh, that's right, I forgot. I made a 3D game engine. It's called Hazel. Now the hardest part of this project is gonna be how do we go from 2D to 3D? Because what does that even mean? Adding a dimension changes the game completely. I mean, it doesn't have to. We could just literally replace the 2D sprites with 3D models and literally keep the game still 2D, so the same 2D physics can apply. You just render 3D models instead of 2D sprites. But that's a bit lame, isn't it? I kind of want to do this properly. Going from Super Mario World to Super Mario 64. Let's make a start on this game, shall we? First thing I want to do is visualize this. I want to put together some sort of scene that lets me get a feel for what it is I'm making and what it's going to look like. Literally, my first step is to find an HDRI, or a skybox. The reason why is because this environment acts as a skylight, which basically determines the core lighting for this scene. And lighting is everything. Without light, you don't see anything. So I just went to polyhaven.com and had a browse through all of their HDRIs to find something that I felt would match with the Genesis aesthetic. You can see here, by the way, just how much of an effect this has. As I go through these different environment maps, the lighting on the actual objects in the scene changes so much. So this literally sets the tone for the scene. So once I've settled, at least for now, on the environment that all this is taking place in, the next step for me is blocking out the scene, just using placeholder cubes. Just show me the ground, show me the characters, what are we dealing with, that maybe it would be worth rotating. Because rotating is not really going to show you much more of the map, is it? But it's just going to make it feel a little bit more if you want to go that way, you can just use the mouse. And this, I think, is such an important step for going from 2D to 3D because it lets you define your camera. How are you looking into this 3D world? Because in 2D, it was just top down, everything's there. It's basically gonna either be top down or a side scroller. But with 3D, we probably want to define some sort of angle for the camera to be at. Is that variable? Can the player change the camera's angle by moving the mouse or something? How far away is the camera from the player? What focal length are we using here? What is the field of view? That all has such a significant effect on what the game looks like, obviously, but also what it feels like to play. So there we have it, a scene with some placeholder cubes and an environment. Looking good. Now we know the mechanics of the game because the game already exists and we have all the code for it even. For example, take a look at this code. This code makes the NPCs walk around. It's just this random piece of code over here. So let's just take that and we'll slap it into this 3D game. Awesome. Now our cubes move around. And then you just keep going. You just keep stealing. Did someone say reproduction? Who was it? Because yeah, that mechanic has to be adapted a little bit because we have prefabs in Hazel and it's the whole concept of oh yeah, let's instantiate entities is different because, well, I just said entities and entities don't really exist in the original version. I mean, they do. There are things called entity, but it's not an entity component system and it's certainly not in a game engine. So obviously all of these minor changes need to happen, but you can see how the game kind of writes itself because it's already written. Anyway, we're not trying to remake this game with cubes. That's not the intention. In fact, I specifically said, let's go from Super Mario World to Super Mario 64. So we have to, well, I mean, for starters, we need some sort of 3D character with animation, right? Like that's what 3D games have. Well, I'm not a 3D artist, and I'm certainly not a 3D character artist. That seems quite hard, to be honest. Where can we get, nay, commission a 3D character to be created for this wonderful game? That is, of course, the 3D realization of our original, I don't know what he's called. I don't know what he's called. I don't know what the female is called. They're these little sprites that I made. We need to find someone. We need to find someone who can do this for us. We need someone to just plop it into reality. Oh, what's this? Where'd I get this from? I bet you'd like to know. I got it from Fiverr, the sponsor of this video. I needed some 3D character models for this game, and I needed them quickly. Not only that, but I needed to find a freelancer who could help me realize my vision. Fiverr connects you with freelancers who can do lots of different things for you. Anything from art, graphic design, web development, video editing, the list just goes on and on. Any digital service you can think of, you'll probably find someone on Fiverr that can do it for you. So naturally, I was like, I need a 3D character model for a game I'm making that's based off of this 2D pixel art thing I made. Wait, can I just tell Fiverr that? Turns out you can, because Fiverr Neo have this new thing, it's an AI assistant that can help you narrow down exactly what you're looking for. Neo will offer the best freelance matches and keep updating them as the conversation continues. Now, freelancers on Fiverr often list clients that they've previously worked with, they share portfolios of their work, and they also have all of these user reviews that you can look through. All of this helps you choose someone that meets your expectations and quality level. After much searching, I decided on Julia to make the 3D characters for this game. She had lots of experience working with past clients. They were all pretty happy judging by these reviews, and her portfolio showed lots and lots of wonderful characters that she had made in the past, whose art style more or less matched what I was thinking for my characters. I started talking to her about my project and seeing if she could design something based off of these silly 2D pixel characters. We went back and forth quite a bit because she wanted to be sure of the vision that I was having, which, as I mentioned, is very important. And once she got started, she sent these progress images, which were great because they let me look at the designs, review them, see what the actual 3D models are looking like, and tweak the proportions, for example, here, because I thought that the head was a little too large for the body. Let's maybe reduce that. Going back and forth here and seeing the character come to life was really cool. I also asked for more details on the textures for these characters because I wanted them to look really good up close if I needed like some, you know, like close-ups for maybe the main menu or promotional art or whatever, because most of the game is going to be like the camera's going to be kind of far away from the characters, but I still wanted that high quality for the close-ups. And well, Julia delivered these 4K PBR textures that have great detail and definitely suit what I was going for. So overall, I had a great experience with Julia. Highly recommend if you need some 3D characters. You can head to fvrr.co/Cherno, link will be in the description below. Check out the services they have available and get 10% off your first order with code Cherno. Huge thank you to Fiverr for making this project possible and for sponsoring this video. I think the characters turned out really well, along with the rest of our placeholder art ready to ship. So the hardest part of this project, but also the part that I wanted to spend a little bit more time on, was going to be the animation. We have a really, really cool animation system in Hazel, thanks to Jim, or 0x, who put a lot of hard work into it. I've made a couple of videos about it, I'll have one of them linked up there. And to be completely honest, apart from like Ludum Dare 55, where I made this game, I haven't really spent too much time with the animation system. But also, I've never personally gone through the process of rigging and animating a character from scratch. And that, specifically the rigging part, was something that I wanted to take the time and actually learn about. I could have just gotten someone on Fiverr to do it, but I like to, you know, learn something new with each project that I do, and it's definitely going to be useful in the future. Rigging, by the way, is the process of taking the bones, the skeleton of the actual animation, and mapping it to the actual geometry, the actual vertices of the character, so that they move along with the skeleton. Turns out Blender has some really nice and easy to use tools for rigging that really helps to accelerate the workflow, and we'll get into those, but I decided to kind of start from the end and work backwards. For this project, I decided that I wanted to use animations from Mixamo. For those of you who don't know, Mixamo is like a website. I think it's owned by Adobe now. It's basically got lots and lots of really high quality motion captured animations that are free to use for whatever project you're working on. They've also got lots of characters that you can actually use that come with animations, but for this, obviously, we didn't need any characters. We just wanted the animations themselves. These animations come with their own skeleton of bones, and the bones are the things that actually move, that actually have the keyframes that produce motion. Since we're planning to use these exact animations to me, it didn't really make much sense to try and make our own skeleton, rig it, set it up in Blender, and then have to retarget all of the Mixamo animations into the bones that we have in our skeleton. So my strategy for this was simply to download the FBX animation without the actual skin, so without the model, without the character from Mixamo, just the skeleton and the animation, import it into our Blender file that contains our character, and then just use that skeleton for rigging. So the Mixamo skeleton with the animation, that's what I'm going to use for rigging. Because my thinking was that if I do it that way, then any animation from Mixamo, because they all use the same skeleton, at least I think they do, all of the animations from Mixamo will just work because they just move the bones and our character is kind of tied to the bones. I've never done any rigging before. I mentioned that. This is my first rigging attempt. It went okay. I mean, you just kind of force these bones to align to the geometry, just kind of move them all into position as best as you can, and then just auto rig it. There are some more advanced things like this, like angle, rotation, orientation, whatever thing. We'll ignore that. I don't really know what that is. So that auto rigging gives us a decent result, but it's not perfect, which is good because you wouldn't want to miss out on the fun that is weight painting. Every time I'm being sarcastic, I want to take a sip from the coffee cup just so that you know that I'm being sarcastic. So these colors here visualize the weight of a certain vertex to a certain bone, with blue being 0 and then going through like green, orange, red, and red is 1. That weight value for each vertex will determine how much that vertex will basically align with the bone. So if it's 0, it's not influenced by the bone at all. It's at whatever position it is. But then as you increase the value, it will sort of pull the vertex more towards the transform of the bone. And since the bones are the things that are animated, that's what makes the vertices move. And that's how skeletons and bones basically work. Because if we just wanted to animate each individual vertex, that would be a lot of data. They'd all have their own transforms. It would just be too much for us to handle. But with a skeleton, we can define way fewer bones and then just grab like a whole bunch of vertices and sort of move them into the transform of the bone. And since the weight changes across the vertices, it sort of gives you like a smooth effect. It doesn't have to. Of course, if you're making like a robot or something, you might want these like rigid constraints and other things, but for this, it works pretty well. So now that that's rigged, we should be able to just drop in any animation we find on Mixamo into our character because they use the same skeleton. At least I think that's how it works. And I say that because for some reason, the animations that I imported and then applied to my character skeleton, they turned out to be a little different for some reason. I'm not sure if that's because I played around with the scale of some of the bones, like the root bone, because I had to make it smaller to fit my character. I mean, what else did I do? I don't really know what else could have caused this. It's not too bad for the idle and the walking animations, which I think are the primary ones I'm gonna end up using. But if we try this picking flower animation I found, for example, you can see that the results side by side are quite different. And since my skeleton ends up basically reaching like below the surface of the ground to pick the flower, it kind of makes it unusable. So if anyone knows why this happened, please let me know. Anyway, for all the animations that we will actually end up using, like the idle one and the walking one, we can add them all into like this one file and just export it as a GLTF. I also added this like drunk running animation. I just wanted it there because I wanted to be able to move faster. And as we'll find out in a minute, movement is dependent on the actual animation itself because we're using root motion. So if I want the character to move faster, I need an animation that moves the character faster, like a running one. So I kind of picked this scary drunk running one. I'm not sure why. I think it kind of looked funny. So now that our characters are all rigged and ready to go, let's get them into Hazel. This process is actually pretty simple. We just export the characters as GLTF files, specifically as a GLB file, which is the binary version of the GLTF file format. So this single file that we just exported contains everything in it. All of the meshes, the animations, the materials, the textures, they're all embedded inside that one file. This will be automatically picked up by Hazel's asset manager as a mesh source asset type, and then you just drag it into the scene to import it. So here we'll import it as a dynamic mesh, which is just a mesh that can be animated amongst other things. We'll import the skeleton, we'll select all of the animations we want, and we'll also get it to create a default animation graph. An animation graph is how we control these animations. And there we go, now our character's in the scene, and you can see that the idle animation is already playing. That's because of the default animation graph that we had it automatically create, which also comes with this index property, which lets us preview all of the animations we have. Now, what we want instead for this animation graph is something that chooses and plays animations based on the speed at which the character is moving. So for example, if we're not moving moving, our speed is 0, we want to play the idle animation. But then as we gradually increase into a walk speed, we want to play the walk animation. And then in the case of our player character with our temporary drunk run animation, we might want to smoothly transition into that when the speed is even higher. Let's just clear our existing animation graph and we'll set this up. So the first thing we'll do is we'll create this movement speed variable as an input into the graph. An input variable is just an external variable. So it's external to the graph. It comes from the outside. It could be set to just a constant value in the editor, or it could be manipulated through C# scripts, for example, which is what we'll end up doing when we add some logic to make our characters move. We can just drag that variable into our graph and then create something called a blend space, which is like a kind of graph that lets us blend smoothly between various animations based on the input, which will be the x-axis of our graph, and that will be our movement speed. Inside the blend space, we can then just drag in all the animations we care about and position them in such a way in the graph that they suit our needs. So remember, the x-axis is our movement speed. So I'll have idle be 0, walk will set at 1, and then run will be 3. So that means that if that movement speed is 3, it will play the run animation. If it's 1, it will play the walk animation. If it's 0, it will play the idle animation. The y-axis in this case doesn't matter at all because we don't even have an input for y, it's just always 0. And so now if we just compile this graph and we take a look at it inside the editor, you can see we have that movement speed variable now that we can manipulate. If I set it to 1, then it's the walk animation. If I set it to 3, it's the run animation. But then because it's a blend space, I can set it to something like 0.5, and you can see it's kind of walking but slowly, and that's because it's blending between the idle and the walk animation. It's halfway between those, and similarly I can increase gradually from walking to running, and it won't just run immediately, it will do something in between based on that movement speed value. So it kind of lets us smoothly interpolate between animations. So from here, now this is set up, we can just control this through our C# scripts as we move. And speaking of C# scripts, it's time to add some logic to this game. I won't bore you too much with the code, or I don't know, should I? But the hardest thing here was managing the orientation of the character. The WASD keys move the character like in the original game, but because this is 3D, I kind of wanted the player to be able to use the mouse to look around. And so as the mouse moves around to look around the world, when the player starts moving, I wanted to rotate the character to face the direction that they were moving in, you know, as you do. And that still gives me a headache. Just the quaternions, and then sometimes there are Euler angles because they exist at some point in like the pipeline, I guess. Anyway, rotation, just the worst. I also tried parenting the camera to like one of the character's bones here. That kind of made it take on the same movement as the bone, so you get this like bouncy camera. I kind of liked it, but I thought that it would get really annoying if you played the game for any length of time. So I decided to just go with a boring, smooth camera instead. So with the characters having some logic now and being able to move around the world, the elephant in the room was the world. Back in the original 2D game, we had these like PNG image files that I made, where every pixel inside that image file represents a tile, and the color of the tile tells you what type that tile is. So for example, blue would be the water ocean tiles, white was just grass, and so on. For a level that's 128 by 128 tiles, back in 2D land, it's not really an issue. The game just renders what tiles are visible within that viewport, and it can just look up what tile type it is to get the appropriate sprite for each tile. But we can't just make our world in Hazel consist of over 16,000 entities, one for each tile. That would be so much unnecessary overhead. We need something smarter. I thought about kind of cheating here by just making a 128 by 128 plane and then giving it the level texture itself, because if you use nearest filtering, then you basically get like these square tiles. Whilst that would be super fast from a performance point of view, it's quite limiting because they're not individual tiles and they're all just like one material with a texture slapped on. And not even just a texture, just a color really, because you're scaling up that 128 by 128 image into a 128 by 128 meter plane. So every pixel in that 128 by 128 texture becomes a 1 by 1 meter tile. So you just have one color per tile. You can't have any detail in the textures whatsoever. So yeah, I didn't really want to do that. It felt kind of cheap and very, very limiting. So I thought about this for a while, and I ultimately decided to introduce a new component into Hazel called the tile renderer component. This would let you set a single mesh and then use instanced rendering to render it really as many times as you wanted. Of course, with different transforms. In this case, just modifying the X and Z translation to spread it out into a grid. I decided on instanced rendering versus batch rendering because this again gives us way more flexibility. We can render the tiles with different materials, as we'll see later, and also we can use any mesh. It doesn't have to be a simple 1x1 plane. We can use something more complex, like a sphere, for example. I added a width and height property to the tile renderer component that lets you define the size of your grid. And this whole system seemed to work pretty well. With a 128x128 sized world, that's 16,384 tiles with no culling, by the way. Performance was barely affected. I think it cost around 1 millisecond. But the problem with this system as it is right now is that it's just all the same. We're rendering all of these tiles with the same material, but we obviously need a way to choose the material based on the tile type, and specifically set these materials based on what was in that level file. So my idea for this was to just have a byte array inside the tile renderer component, which would define the material ID or the material index for each individual tile. So in the case of our 128x128 level, we have an array with 16,384 bytes. Each of those corresponds to a tile and lets us define a material ID between 0 and 255. I thought that 256 different materials would be enough. This ID index matches the list of materials that we can define on the component itself. You can just add a material slot at a particular index and then drag in any material. And you can keep adding materials until you reach 256. So here, just to test this out, I've added 3 different materials here, and then in the C++ code, I've filled this material ID array with the numbers 0 to 2 repeating over and over again, and that gives us this result. And then now, instead of setting these values in C++, we just need to be able to set them from C#, because C# is where our game logic is and where we're reading that level file. So over here in C#, we can read the level file, check to see what color appears for that tile inside the level file, and then use that to set the appropriate material ID. And there we go, we have our level. One of the cool things about this is that we can switch our materials per tile type just from the editor over here. So if I wanted the ocean to be frozen, for example, I could just change out that material. And of course, these are all real individual materials, which means that we can actually use different shaders. Something I really want to do in the future is make a really nice ocean water shader that I can use for those water tiles instead of just a blue material. I think that would be really cool. So with the world tiles working, I did a little bit more work on the game mechanics, namely reproduction. Colliding with a female spawns children, you know, just like the real world. At first, the children were just these placeholder cubes because this actually uncovered an issue that we had in Hazel. And that was that any entities with character controller components weren't able to be dynamically created during like a scene's runtime. Basically what that means is if you have a prefab that has a character controller somewhere within it, it's not able to just spawn during your actual gameplay. You have to have that ready to go when the scene starts. Obviously, we're trying to spawn characters dynamically, like as the scene is played, as the game is played. I don't know if this was like a recent bug that happened, because I'm pretty sure I was spawning in characters in that Ludum Dare game that I made because we had waves and waves of enemies. But nevertheless, that was fixed rather quickly, and we were able to replace the placeholder cubes with the actual models, which are just mini versions of the male model. And with that mechanic in the game, it was finally starting to feel like the original. And so where do we go from here? Well, there are lots of questions to think about. The biggest thing that I ran into at this stage was, how does the world function with the character? Because in the 2D game, you just go up to these like ocean tiles here and you can't go into the water. But over here in the 3D version, it's a bit different for a couple of reasons. First of all, remember, we're using that tile renderer component. So none of these tiles actually have physics. The reason the player doesn't fall through the ground is because we actually have just a ground plane, a plane with no renderable geometry, but it is a box collider that is essentially a static rigid body, which means that the player does not fall through it. But for the player to not be able to enter the water, there would need to be some kind of wall in the way, which we would have to generate. I'm not sure if we would want to create like a mesh collider that just encompasses the whole world, or rather the division between land and sea, or by having just a bunch of box colliders on the first water tile after a land one. But the reason why I didn't go ahead and do any of this is because it just feels weird in a 3D space to just block the player from transitioning, you know, from going into the water basically. It just seems kind of cheap to have an invisible wall that stops the player from going any further. I'd like to avoid that. So I kind of figured that was a good place to stop and ask you guys, what do you think? How should we solve this like game mechanic issue that arose from transitioning from 2D to 3D? Because the rest of the level kind of makes sense. Like we have these rocks, by the way, which, did I mention that I made those in Blender? They look kind of cool. I'm kind of proud of them. I was gonna say this has a lot of cool detail, but this does kind of as well, surprisingly. Because this is just a solid color, but it kind of looks cool, doesn't it? I thought they turned out great. But they're 3D, obviously, and the trees that we'll add later, they're also 3D, and the flowers, and maybe one day we'll even have grass rendering. All of that stuff is 3D, but the transition from the grass into the water that we can't access. Like maybe we could just make the water lower and it's kind of like a cliff and you just can't go off the cliff, or if you try and go off the cliff, you just die. I don't know. If you guys have any ideas, leave them in the comment section below. If someone comes up with a good idea, we're gonna go with it in the next video. Huge thank you to Fiverr once again for making this project possible and for sponsoring this video. Don't forget you guys can go to fvrr.co/Cherno and use code Cherno to get 10% off your first order. I'll see you guys next time. Goodbye.